Hello everybody and welcome to Newton's Laws Style Show. Today we will be demonstrating all three of Newton's laws using real examples from around your school. We will be explaining the vocabulary, the equations, and the physics behind each law. Newton's first law says that an object at rest will stay at rest and an object in motion stays in motion unless acted upon by an unbalanced force. This explains the concept of inertia, which is the tendency of an object to resist a change in motion. Stand by for example. This is an example of Newton's first law, which is also called the law of inertia. The backpack will not move unless a force is acted upon it. Once it moves, it will keep going if friction didn't slow it down. Friction is the unbalanced force that stops it. That's inertia in action. Next is Newton's second law. This law explains how force, mass, and acceleration are related. The law states that the acceleration of an object depends directly on the net force acted upon it and its mass. The equation force is mass times acceleration. When a model stops walking, their body wants to keep moving forward. That's inertia too. The empty chair has a small mass, so with the same force, it accelerates a lot. When mass increases, the acceleration decreases. Same force, different acceleration. Go. To get the heavy chair to accelerate more, you must apply a greater force. That is exactly what F equals m times a describes. Finally, Newton's third law. For every action, there is an equal and opposite reaction, which means the forces must always come in pairs. When you jump and push down on the ground pushes you upward with an equal and opposite force. That upward reaction forces will lift you. Go. When one person pushes, the other pushes back with an equal force in the opposite direction. That's an action-reaction force pair. Newton's greatest achievement in physics was proving that the same physical laws govern the entire universe. Before his works, physics was split. Scientists believed that earthly objects followed one set of rules, while stars and planets followed another, the perfect celestial set. Newton demolished this divide with his law of universal gravitation. He mathematically proved that the gravitational force between two objects depended on their masses and the distances between them. By showing that this singular equation explained both a stone falling on Earth and the moon orbiting our planet, he unified physics into a single universal science. He came up with his own experiments with the existing disconnected physics theories of his peers. By applying his newly invented calculus to these concepts, he turned philosophical ideas into mathematical laws. And that completes Newton's Law Style Show. Today we demonstrated Newton's first law, inertia and unbalanced forces, Newton's second law, the equation F equals m times a and how mass affects acceleration, Newton's third law, action-reaction force pairs, and these three laws explain almost all motion we see every day. Good luck, son. Oh, you didn't say go? I was waiting for the go. Go. To get the heavy chair to accelerate. Very still, but don't. Like